Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today I am gonna explain the concept of send and receive functions of MPI. As we have already demonstrated how to set up Visual Studio for MPI programming along with a simple Hello World program in the previous video. So the description of that video will be available in the link of that video will be available in the description of this video. So since in message passing interface or MPI, the communication is a central concept. So for communication in message passing interface, we have the two basic functions called as send and receive. So in this video, I'm gonna show you in the first part how to use very quickly how to use send and receive function in an MPI program, and then in second part of this video I will be explaining each and every aspect of send and receive function, the concepts, and one by one the arguments sent to and received by the send and receive function. So let's start with starting our Visual Studio. Here is our Visual Studio window open. So this is the main program. I have made a new project named as simple send receive, and here I start the program as starting MPI init. So to use MPI init, we need to include mpi.h. Okay, then after initting the infrastructure for our MPI program, now I will see the MPI com rank, and here inside the com rank I have two arguments. First I will use MPI com world. This is a default communicator. I will be explaining this the communicators in my second part of this video, and here I will be using a variable rank. For that I have to declare a variable rank. Both of these arguments will be explained in my second part of this video. So here I will be using so now since I have to use send and receive function, so first of all I will be here I will be considering the point-to-point communication. That's a process will send a message and another process will receive that. So there will be two processes, mainly the sending process and receiving process. Let us consider the sending process as process 0 with rank 0. So I will be saying if rank equal to 0, then if the process rank equal to 0, then the process has to send a message. So for that I will be using MPI Send. This is my MPI Send function, and here in MPI Send function we have various arguments. The first one will be the constant buffer. So let me send a simple x. This is a variable of type integer, and how many elements I have to send, how many integers in this case I have to send, that's 1. And what will be the data type of that sending? That will be int, MPI int. And then the destination the process that the rank of the destination process. Let us suppose that's process 1, and then we have message tag, let it be 1, and then MPI convert, and I will say it's MPI, the default one, the default constant I will be using, MPI convert. Okay, so here there's an error. This is that I have to declare an integer x with some value, and here if the process rank equal to 0, the responsibility of the process here is to send a message to a process whose ID is 1. Okay, then else if the process rank is not equal to 0, it can be 1, 2, 3, but in our case there will be only, in our simple case there will be only 2 processes, one is sending and one is receiving. So if the process rank is not equal to 0, it can be 1, 2 or 3. So in our case it will be 1, and here the process 1 is responsible for receiving this message. So I will use this MPI receive, and inside MPI receive we have the arguments. First one will be the buffer argument, so I will be sending a simple integer variable, that's y, and I am expecting one integer, and that expected integer will be of data type int. And then we have source, the rank of the source process, that's 0, and then we have message tag, so the message tag will be 1 because I am using 1 here. So I am sending this message to this receive, so that this another process will receive it here. So I will be explaining one by one what will be meaning of what will be the difference of message tag and message source in the second part of this video. And here will be MPI convert. So this is the constant, and here there will be one more additional argument, that's MPI status, of type MPI status, and I will be sending and status to this. So here is y, so I have to make this y here. For example, I will make integer y, that's gone, and here I need to make a status variable. So here I will be making MPI status, MPI status. This is MPI status, and here I will name it as status symbol. Okay, so here I am sending a message, and inside the message I am sending a simple integer variable x to this another process where it receives it, and here it receives it and gets it this sent message or sent data in y, and these are the details. So let us now simply display the result to check whether it came or not. So here I will use printf. Received data, that will be an integer, and here that will be y. Okay, so here I am initializing of my MPI program, and I need to finalize it also. MPI finalize. Okay, so let us build this quickly. This is built, and then I will take this path and opening my command prompt. I have copied this same path and I will paste it for simplicity, and here I have to reach to debug, and then I want to run this, execute this. Then there will be a command MPI exec, MPI exec, MPI exec, and then number of processes I want 2, and program name, that's simple send receive.exe. I will enter this. Same problem with the Avast wants to check. Okay, so here I will execute it again because of this antivirus. I got some error message. Now if I execute it again, so you can see here received data 10. So you can see here I am calling this send function over here with my integer variable x with value 10, and here I am receiving the same integer in y, and then here I am displaying the y. This is the only printf function which I am using, and here is the result. Okay, so now we are done with first part of my video. Now we will dissect this program step by step, and we will see the structure of the program, structure of any MPI program, and when we are using our send and receive functions, what will be the required arguments for that. And first of all, we will be having the concept of communicators in our MPI programs. Since in message passing interface, the important concept is the communication. The communication needs identifiers, whether it's a sender or receiver. For example, if I am sending a message to any receiver, he should know from which I am receiving, from whom I am receiving this message. And similarly, if I am sending a message to any receiver, I should know his identification to whom I am sending this. Receiver should know from whom I am getting this message, and our sender should know to whom I am sending this message. So the communicator in the communicators, the communicator actually defines the communication domain of communication operation. So in a single communicator, we can have set of processes that are allowed to communicate among themselves. So here let us suppose we have in our communicator we have processes as P1, P2, P3 and P4. And in our case, if for example P1 wants to communicate with P2, and P3 want to communicate with P4, and P2 again want to communicate for P4. So let us take this scenario as if we have P1, P2, P3 and P4, and then P1 wants to communicate with P2, and P3 want to communicate with P4, and P2 want to communicate in P4 in our scenario, in our whole scenario. So what we have to do is we have to define a communicator C1, for example, for communication of P1 to P2, and another communicator C2 as P3 to P4, and another communicator C3 which will cover up the communication of process from process P2 to P4. So this is the concept of communicators, because here in MPI com rank or in any of the functions we are using repeatedly the MPI com world. So here we are using MPI com world. This MPI com world is a default. This is a default constant. If we want to adjust, or if we want to have all the processes in this program in one communicator, a default communicator, so we can use this MPI com world constant to instruct that each of the processes will be belonging to this MPI com world. So that's why I am using this MPI com here, MPI com world over here. Another thing here is the process rank. This is the rank of the process. So in our MPI world, each process has one unique rank. That's process ID, the identification of a process. So each communicator have multiple number of processes, and within a communicator we can have process ranks. Each process will be having a unique rank, starting from 0 to n-1 if we have n number of processes in a particular communicator. So you remember in PIDs in Unix and Linux, which is unique on one processor, the unique process ID on one processor, but not possibly across all processors. So notion of rank abstracts the notion of PID to a level beyond the individual processors. Within a given communicator, the different processes communicating each other through the communicator are assigned a rank from 0 to n-1, assuming that there are n number of processes within a communicator. So this rank will be unique for each and every process in our communicator. After this MPI com rank, we have MPI Send. Previously I have explained why I am using this if statement over here. So here is the MPI Send. The first argument for the MPI Send will be the buffer. So in this case I am using X as the sending message, the contents of the message, and after that there will be count, how many elements I am sending. In this case I am sending an integer. For example, if I am sending an array of integers, and within that array, if for example that array is of 10 elements and I want to send that integer array as my message, so I can mention here as 10. Or else if I want to have this 10 elements array, and out of that 10 elements array I want to send first 5 elements to this, so I can mention here the 5, the number of elements I am sending. And since we have some inbuilt MPI data types, like for integer we have MPI int, for float we have MPI float, and etc. So we are using here which data type I'm gonna send to the receive message to receive by the receiving process. And after that we will be having the rank of the destination process, because we can have many processes in our communicator as explained earlier. So if we have a process 0, process 1, process 2, and I want to send from process 0 to process 1 or 2 or 3, so this will be the destination process rank over here. And then we have a message tag. Since in cooperating processes they may need to send several messages to each other. Used to differentiate between this message tag is used to differentiate between different types of message being sent. For example, if we care of corresponding order of matches for sends and receives. For example, if I have this send message over here and I want this send message to be received by this corresponding receive. So because we can have multiple sends, for example by process 0 I want to send MPI send once, and again I want to send MPI send another, I will call it again. For example, I want to send 2 messages to the process, so I can use here the and X. Let us change this X equal to X plus 10. First changing the contents of X, then I will say it will be again one element, and then it will be MPI int type, and then it will be having the destination process same as destination, the process with rank 1, and the message tag, since this message is different from this message, so I will change here the message tag as 2, and here it belongs to same MPI, same communicator. So this is in our case the default one, MPI com world. And here MPI receive and Y I can simply copy this statement. Since here I am using the different message tag, so this means that now this message will be sent to this receive, or I can say this receive function will receive the message from this send because their message tags are matching. Okay, and this receive will receive this. If we care of if the matching is not required, we can use MPI any tag. I will show you afterwards how to use MPI any tag constant as a wildcard. So, but if we want to have the corresponding match, like it's not guaranteed that this send will be performed, executed first, and then this. There will be no sequence guarantee. So this can, if we are not mentioning this message tag, so if I am sending and this message is intended, for example, to this receive, and this send is intended to this receive, and I am not mentioning the tag, message tag, it's not guaranteed that this message will be sent to this and this message will be sent to this. So that's why we are using separate the process ID, or we can say the process rank, and the message tag, the message identifier, as to which receive this message is intended to. Okay, so if we are not concerned about the matching or the sequence of the message here, and this send will be received by this or this, no problem. So instead of this message tag, we can use MPI any tag, like this. MPI any tag is an inbuilt constant, and here I can also use MPI any tag, and here MPI any tag, MPI any tag. So any send corresponding to receive can send any message to any this send, and this can match with this or this, no problem. But if we really care about, no, this send should be received by this receive and this send by this receive, so in that case we have to use the corresponding message tags. Similarly, if for example we can use another this wildcard MPI any source. For example, here, if in case of the receive function, since we have in the receive function we have our the source process from which I am getting the message. If I am not caring about who is sending me the message, any source if sends a message, I want to receive it and display it or maybe act upon it, I can use MPI any source. This MPI any source. There are many tags MPI any source. There are many constants MPI any source, or we can say the MPI any tag used as a tag, used in the tag argument, and here inside the source argument I can use MPI any source. But here I know this is a point-to-point communication from a particular process that's ranked as 0, and I know that this process when sends a message it should be received here, so I can mention a particular process rank over there. So this is all about the MPI send and almost MPI receive functions, but here is an additional argument in MPI receive function, that's status. So the MPI status or MPI status structure, by this we can, this argument is an additional in this, so we can check this some status structures inside after receiving the data. For example, if I want to see here the status, there are three things, that status dot MPI error, status dot source, status dot tag. So if there is some error and I want to display which type of error this is on receiving, and if I want to display from which source I got this message, and if I want to know the message tag, so I can use this status. So for example, if I say MPI source, and here I use, because source will be the rank of the process who is sending the message. So I will say int s equal to status dot MPI source, and similarly I can use integer for my tag, t equal to source dot tag, source dot MPI tag. Sorry, status dot MPI tag. And afterwards I can again printf or what else. So these are some important concepts and some important things we should know about using send and receive function. So that's all for today. Thank you very much for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.